Hi, today we're going to talk about matter, specifically elements, compounds, and mixtures. So, section 3.1. Matter can be classified as a pure substance or a mixture. Those are two large categories, okay? So, what is matter? Matter is anything that has mass and takes up space. And then matter is broken into a pure substance. A pure substance has what's called a fixed composition. So a fixed composition, let me change my ink pen here. I think I'm going to go with blue. What does fixed or constant mean? It means that it just doesn't change. In this case, the makeup of the substance never changes. That's what fixed or constant means, is that it's not going to change. For example, water. Water is a pure substance. Water is always H2O. Anytime you find water, that's always the same chemical formula. It's constant, it's fixed. Pure substances can be either elements or compounds. Okay, so again, matter can be a pure substance or a mixture. We're talking about just pure substances at this point. One type of pure substance is what's called an element. Elements are made of only one type of atom. So for instance, silver. Silver is an element. It's only made of silver atoms. These are all found on the periodic table. So if it's not a name or an element on the element symbol on the periodic table, then it's not going to be an element. So in your notes, you have a periodic table. So here's one of our periodic tables that we use. So let's take a look close here. Let's say copper, right? Here's copper right here. So that's Cu, and it's copper. That's an atom. It's only made of one thing, and that's all there is. Okay? So anything that's on this periodic table is an element. If it's not on this periodic table, it's not an element. I'm going to switch back to my notes. So here we go. So again, elements found on the periodic table. What you're looking for whenever you're asked, is this an element? You're looking for the name of that element all by itself. Okay, so for example, name or the symbol. Okay, H2O. There's a capital H and there's a capital O. That means that that's a compound. That is not an element. I'll give you another example. Ag. Ag is one capital letter, A, lowercase g. That is an element because it's only one thing. All right, give you another example here. Ca, one capital letter, one lowercase letter. That's an element symbol. Give you another one that's not an element here. Let's say Na. Na all by itself would be an element, but now Cl. Notice we have two capital letters, the N and the C. The capital letter lets you know that that's a different element. So Na is sodium, Cl is chlorine. Elements always have the same properties, and they cannot be broken down at all. What that means is when you break down the element sodium, it's no longer the element sodium. You cannot break down an element at all. Okay, you only get protons, neutrons, and electrons. We'll see a difference with that when we talk about compounds. Let's look at some pictures and words here. So we already looked at some words, right? We said that's an element, that's an element. This is not an element. All right. If we're looking at pictures, boy, something's going wacky there, huh? If we see a whole bunch of just one type of atom, so these are all blue shaded in circles to represent blue atoms, that's an element. Okay? Show you an example of one that's not. So now we have two different types of atoms are attached like that. That's not going to be an element because it's two different atoms attached. Okay? Compounds. Let's talk about compounds. We somewhat mentioned compounds earlier. These are going to be two or more elements that are chemically combined. Right? They are made of elements put together. So a great example here is sodium chloride. Sodium chloride is a compound. What you're looking for is more than one element in the formula. So let me give you another example here. Mg, that's an element, magnesium. O. O is an element, oxygen. MgO is a compound. So that's no longer an element, it's two elements that are combined, which makes it a compound. Now, these can be broken down, and they're broken down by chemical reactions. So we have to mix this magnesium O, this magnesium oxide, with something else to get it to break down. Okay. Let's look at some examples here. I gave you this one, right? So that's one. Let's look at another one. A great example is this substance, which is got some just white ones attached to it, right? So that's water. That's what water typically looks like. Water is made up of oxygen and then two hydrogens. So the formula of water is H2O. All right? So that's matter, pure substances, elements, and compounds. All right, so if we look at this picture, this sort of gives us an idea of how a compound and an element are related to each other. So here is a compound, go away. Here is a compound, sodium chloride. So the formula for that is just NaCl, okay? Now, that NaCl can be broken down by chemical means to give me sodium metal, which is just Na, and chlorine gas. In this case, chlorine gas is a little bit different, it's Cl2. But it's still just one type of atom. So we still call this an element. So we have a compound breaking down to two elements.